In this lesson, I'm going to talk about isosceles and equilateral triangles. First, an isosceles triangle. It's any triangle that has at least two congruent sides. If you have two congruent sides, you're an isosceles triangle. And then the way we name it's like the two congruent sides are called the legs, and then the non-congruent sides called the base. Now, here's the thing. Since the legs are congruent, that means the angles opposite them are congruent, and we call those the base angles. Those base angles are congruent. And the vertex angle is just the angle opposite the base. Now, here's a theorem, the base angles theorem. If two sides of a triangle are congruent, if these two sides are congruent, then the angles opposite them are congruent. Because if these are congruent, that means that they share the same length, which means the angles should open up to the same length. Two sides congruent, then the angles opposite them are congruent. Find the measure of each angle. Keep in mind that if we look at it, these two sides are the same. And if those two sides are the same, that means that the angles opposite them are the same. This angle over here is equal to this angle over there. So x is equal to 35, 35. And then now how are we going to solve for angle y? Well, it's a triangle. Triangles are always 180. If I have y plus 35 plus 35, it's going to equal 180. Let's do a little math. Y plus 70 equals 180. Subtract 70 from both sides. Y is going to equal 110, 110 degrees. Example B here. All we have to do is find x. Now, what we have, though, is, again, these two sides are congruent. That means the angles opposite them are congruent. This guy's going to be equal to this guy. So 3x plus 3 is going to equal 5x minus 9. And all we want to do is get the x by itself. I always like to get rid of the smaller x. Let's get rid of this 3x here. We're going to minus it from both sides. It's currently positive. These cancel out. We get 3 is equal to 5 minus 3 is 2x minus 9. And then what we want to do now is get rid of that negative 9. We want to isolate the x here. Let's add 9 to both sides. These cancel out. And we get 12 is equal to 2x. Then we just divide both sides by 2. And we get x equals 3. So there you go. Next, the converse theorem also works. So if you have two base angles the same, then the sides opposite them are congruent. So for example, here, I see that these are both 35 degrees. That means that this side is going to match this side. We're just going to do 2x minus 8 equals x plus 3. If I see these congruent, that means that it's an isosceles triangle, which means it has two sides congruent, and specifically the sides opposite them. We'll try to get the x by itself. So let's get rid of the smaller x. Minus x from both sides. These cancel out. We get 1x minus 8 is equal to 3. We'll get rid of that negative 8 plus 8 to both sides. And we get x is equal to 11. Over here, if I want to find the perimeter, well, first we got to find out what x is. This angle is equal to this angle. That means that this side is equal to that side. 3x plus 7 is equal to 4x minus 2. Same concept, I want to get rid of this x, so minus 3x from both sides. We get 7 is equal to x minus 2. Now let's get rid of this minus 2. We get x is equal to 9. Now in this problem, we're not done because it didn't say find x, it said find the perimeter. But now we know what x is. We can substitute it in. Right here, it's a 9. I get 4 times 9 minus 2. 36 minus 2 is 34. That's how long this side is. Over here, x is 9. 3 times 9 plus 7. That's 27 plus 7. 30 isosceles, so I should have just gone 34 and 34. This side here, 5 times 9 plus 1. That's 45 plus 1, 46. So my three sides are 34 plus 34 plus 46. We're going to add them two at a time. That's 68 plus 46. So that's going to get me 4, 1, 11. 114. The perimeter is 114. Okay. Next, perpendicular bisector by isosceles triangles. Perpendicular bisector is something that cuts a line in half and it makes it a right angle. Bisector means cut in half, and then perpendicular means it makes it a right angle, 90-degree angle there. We're going to do that to an isosceles triangle. That's this theorem. If a segment bisects the vertex of an isosceles triangle, we have an isosceles triangle like this, and then we're going to bisect that angle in half. Remember, bisect means cut in half. Then that segment is also a perpendicular bisector. If this is true, that means that this bottom part is also 90 degrees and perpendicular. Or I should say perpendicular, which is 90 degrees, and it bisects it, cuts in half. If we have this, then this is also true. Okay, we're going to use that to solve this problem here. A prefabricated house is delivered to a foundation in two symmetric halves that are assembled on site. Along the planned delivery route, the delivery truck must pass under a bridge that has a clearance of 20 feet. The truck has a bed 30 feet from the ground. The truck driver planned a different route to deliver the house. We want to see how high this is. If this is 20 meters high, then that's too high. We're going to need the clearance. If this is like 15, then we're going to be good, because 15 plus the 3 is still less than 20. We got to figure out the height of this guy. Draw it like this, what's going on, and then we have this. So I guess we should draw a diagram here like that. Then the base, we have that, and then this is 28, this is 10, we know this is 16 and 16. This got cut in half, got bisected, which means that these two guys are the same. It's a perpendicular bisector, which since we know the bottom here is 28, that means each side must be 14. And we can use that to figure out the height here, because that's the only thing we don't know is this height. I know the height here. This height is 10. Whatever this height here, that's going to we're going to add the 10 plus that, and that lets us know if it's too big or too small. How do we find that? Well, it's a right triangle. We could use the Pythagorean theorem. I'm going to do 14 squared. Now remember, when you do the Pythagorean theorem, a squared plus b squared equals c squared. It only works for right triangles. And the one general rule besides right triangles, okay, it's the two rules. One has to be a right triangle, and then two, c has to be a hypotenuse. My hypotenuse is always opposite the 90-degree angle. So this is my hypotenuse. A and b don't matter. It could be a, that could be a, it doesn't matter. C has to be hypotenuse. We're going to do 14 squared plus x squared equals 16 squared. We get 196 plus x squared equals 256. And we're going to subtract 196 from both sides. X squared is going to equal 60. And then we're going to square root both sides like that. I don't know the square root of 60. I need a calculator. I'm going to do it off camera, but that's going to turn out to be about 7.7, approximate 7.7 feet. But we know the height here now is about 7.7. What we got to do is figure out the whole height from here to here. Is add up our 10 plus our 7.7 plus, don't forget, the height of the bed. The truck has a 3 feet bed-ish. So plus the 3 feet bed, and we actually get 20.7. You get 10 plus 7, 17 plus 3 is 20 plus 0.7. So 27, so it's too high. We need an alternate route. Okay, that's that one. Let's move on to equilateral triangles. So an equilateral triangle is exactly what it sounds like. All the sides are equal and all the angles are equal. We have kind of the same theorem as we do for isosceles triangles. If the triangle is equilateral, then it's also equiangular. Equiangular just means all the angles are the same. All angles congruent. Equilateral, all sides congruent. If all the sides are congruent, then all the angles are congruent, and then vice versa. If all the angles are congruent, then all the sides are congruent. We have a name for that term. It's called regular. If you ever hear someone say it's a regular figure, a regular polygon, a regular triangle, this means all the sides and all the angles are congruent. Is an equilateral triangle an isosceles triangle? Yes. Isosceles just says two sides the same. And actually, an equilateral triangle is a special type of isosceles triangle. The special type where all the sides are equal. Okay, let's do a couple of examples and then we are done. Find the measure of each angle. So we want to find all the missing angles here. First, let's look at the markings. Over here, all the sides are marked off. I know these all have to be 60. Automatically, any equilateral triangle is always 60 because you get 180, all the angles, divided by 3 equal sides, and you get 60. Automatically all 60. Over here, these sides are marked off. This is an isosceles triangle on this side, which means the angles opposite are congruent. Angles opposite the base. The angles opposite the congruent sides are congruent also. That's 50. This side's also 50. The only thing we need left is this angle right here. And I'm going to solve that by the fact that we know all triangles are 180 degrees. If I just look at this triangle here, I know that's 180 degrees. I'm going to do 180 minus 50 minus 50. I get, what's 180 minus 100? 80. This guy right here is 80 degrees. And that's the lesson.